Resume recording. Okay. Okay, good afternoon, guys. Last time we formulated the electric potential, and then we tried this example, getting the potential, of course, sa isang spherical shell of radius r given in this figure. Okay? Nasagot na natin yung electric field nito, so ginamit natin yung results ng Gauss's law, which is electric field. So E.dl yung ginawa natin pag-solve ng V. Sir, kala ko ba mapadali yung mga sumusunod na lesson from the definition of electric field is pampadali ng buhay natin. Di ba? Yung Gauss's law, pampadali ng buhay natin yun. Yung electric potential, however, sir, bakit mo ginamit yung electric field? Di ba nga yung electric field nga yung dapat hinahanap natin? So parang ang daya naman nun, sir. Hindi nga natin alam yung electric field dapat, di ba? Okay, so kung lang mag-given sa yung electric field, pwede mo magamit na. Okay? So, ito na yung real deal. So, for a potential, sa mga charge distribution natin na may rho, sigma, and lambda, we have this potential for that. So, parang similar siya dun sa electric field natin, sa calculation ng electric field natin. But notice from here that there is no direction. Di ba yung electric field natin, E of R, is somewhat like this, 1 over 4 pi epsilon naught, rho of R prime kung nasaan siya. Then the separation vector, tapos yung direction, no? R squared, d tau prime. Di ba ganyan yung electric field formulation natin last time? And this is very difficult kasi lagi mo iniisip yung R hat. Sino yung magka-cancel, sino yung hindi magka-cancel out. And kapag nagkamali, kapag nagtae ka pa dun sa pag-solve mo nung direction, malay mo pala, hindi pala magka-cancel out yung pinag-cancel out mo, hindi sabog na yung solution mo. That's very confusing, tama? So we have now is yung ganitong formulation. And tingnan natin kung gaano kadali ito. Okay, so we have an example. Find the potential of a uniformly charged spherical shell. So again, yung spherical shell pa rin yung sinosolve natin. Diba? Parang kanina lang. But this time, we don't know the electric field. Sabihin natin we don't know the electric field. Okay? Okay, so let me get my notes. May notes na ako para hindi na tayo mamabagay. Akala mo maano. Akala mo masyadong mabagal. Okay, ito. Sorry. Ano ko sinasabi? Sa mga mahilig magkape, no? Lakas ng Nescafe strong. Wala na, nagpa-plug. Grabe. I feel alive. Pati yung kaluluwa mo, buhay din. Okay, potential, VR, can be also written as 1 over 4 pi epsilon naught in the integral for sigma, okay? dA, and then, oops, sorry. Next lang line na lowest. Yung separation vector mo, that's it, right? Okay, so ito yung pag surface yung gamit mo. Kanina, given lang natin is yung volume charge distribution rho, but in similar way, ganito lang din yung lalabas sa surface. Okay? Nasa libro yan na yung line charge will be 4 lines. 4 lines charge. That will be V of R and then 1 over 4 pi epsilon naught tapos lambda dl. Ganun lang, diba? Oops, ano yun? Labo naman yun. dl tapos R. Okay, very simple. Now what we're gonna do is of course plug in the things that we know. Okay, let's do this. White na lang muna. Okay, PJ, ano yung R? R squared. Sige, R squared. Ayan. R squared. Are you there, PJ? Wala si PJ. Jello. Sige, si Jello na lang. Saluhin mo si PJ.
Sir, yung nasa book po ay wait.
Ito yung ano.
R,
ito yung R mo. R squared.
ano po, big R squared plus
Okay, big
Z
R squared. Okay.
minus 2RZ cosine theta prime.
Okay, very good. So as usual, we have R squared. Of cosine lang to, di ba? Minus 2RZ cosine, ano ba yan? Cosine theta. Theta na lang, okay na. Kaya ma-confusing na theta at theta prime. I mean, wala nang ibang theta dyan. Okay, next will be si Charles. Nandiyan ka ba, Charles? Right there, Charles. Oh, wala si Charles. Okay, sige, okay lang yan. Si Alexandra. Okay, right there. Ay, dito nag-chat. Si Charles, dito. Okay. Charles, ano yung dA, yung infinitesimal surface for a spherical shell? Ayan. Spherical shell, ano yung dA? Type mo na lang.
Yung value po
Ay,
ba,
okay.
sir?
Yung dA, ano yung infinitesimal charge? Ay, infinitesimal surface.
R squared sine theta d theta d tau. Yun po ba, sir? Hindi ko sure.
Okay. So, slowly. dA.
R squared sine theta d
R squared
theta
sine theta. D theta. Tsaka?
d tau. D tau.
Okay. Mali. So, mali lang ng variable. Okay. Ito ay tinatawag na phi. Okay? Ito yung phi. Okay. So, yung phi ay nagro-rotate again. Yung theta is ito. Ayan. Theta is pala. Okay. And then yung phi will be rotating from this guy. Okay? So, si phi ayan. Okay. Okay. So, that's it. We have all that we need. Tama? O plug in na lang natin to. Madali na lang. So you have your V that will be 1 over 4 pi epsilon naught. Then integrate it. Kaso dalawa ng integral natin dahil may d phi at may d theta. So we have 0 to 2 pi and 0 to pi. Tama? Tapos we just plug in things. Sigma is uniform. Tapos dA mo will be r squared sine theta d theta d phi. Okay, very straightforward pa naman. Then I have r. ER ko muna to. Okay? So may gagawin akong trick. No? So nakita niyo na yung solution sa prob set natin, sa unang prob set. Ang ginawa ko is para maging trivial yung ano natin, problem natin, I take the derivative of this. So magiging 2 r dr. And then zero out yung big R squared dahil constant siya. Si Z squared din, constant din yan. Then I'm left with 2r z sine theta, d theta. And we can see that itong sine theta, r sine theta, pwede may pasok dito, di ba? We can simply do cancel. We have r, dr, tapos divide ko to by z para matitira na lang is r sine theta, d theta. And now I can use this fact here. So I'm left with, integrate na natin si d phi dahil wala namang phi elsewhere. Kay separation vector, wala din naman. Puro theta lang. So si phi ay free to integrate. And mag-accumulate lang ako ng 2 pi factor. So let's do that. Hindi ko muna pagsasamahin yung bagay-bagay para makita natin. 1 over 4 pi epsilon naught. Tapos sigma. Tama. Then I have 2 pi for the phi integral. Then I have the integral. Okay, the integral. Then again, I just put r here. Then you have r squared sine theta d theta. I'll split r squared sa r lang kasi may r sine theta na sa kabila. Okay, so split ko yung r lang. May matitirang r, tapos yung r sine theta, d theta, magiging ganito. So r dr over z. Nakakalito yung mga r, no? Ang daming r. R dr, d curly r, z. Okay. And simply, we have cancel out. And the integral is now very trivial. Okay. I have 1 over 4 pi epsilon naught. Tapos, I have... Oops, may mali. Okay, wala pala. Kala ko may mali ako. Double check nito. Okay, I have sigma 2 pi r. Sigma 2 pi r. Tama. Tapos, okay, ang mangyayari ay may r ako, tama? Na-integrate lang to sa with respect to dr. Ay, may over z na. Ayan. Okay, over z. Okay, tapos i-evaluate natin to sa lower bounds and upper bounds niya. Then, kung mapansin nyo, may 2 cases tayo. Again, kapag z is outside r, and then kapag si z less than r. Less than r. Okay? Kapag si z greater than r, which means, ayan, ito nasa image natin, ganito siya kahaba kunyari, ano yung values ni, sir, bakit po 0 to pi yung bounds na integral, ng isang integral? Okay. 0 to pi yung bound ng ng theta, okay? Tapos yung phi ay, yung phi kasi whole revolution, so that is 2 pi. Yung theta mo hanggang sa kabilang axis lang. Hanggang negative z lang. Okay, so that is just pi. Kuha ba? Chat naman kung kuha. Okay. Okay, so going back. So kailangan natin malaman yung bounds ng curly r, di ba? So kapag si z ay greater than r, ibig sabihin nasa labas siya, then what is the minimum value of curly r? Then that would be lower. That would be yung z mo minus r. Tama? So itong part lang na yun. Tapos yung maximum value niya will be this guy. So that is z plus r. Upper. Z plus r. Very simple. And then kapag si z ay less than r, ibig sabihin nasa loob, sabihin natin nandito si z. Iba na tayo. Red na lang tayo. Sabihin natin nandito si z sa loob. Ano yung minimum value ni r? That would be from the radius to this point. So that is r minus z. R lower. R minus z. Tapos r upper. will be from this point to this point. So that is Z plus R. Z plus R. Alternatively, pwede naman yung ginagawa nyo na balik ka dito sa definition mo. Plug in mo yung theta na 0, then plug in yung theta na phi. Ay, pi, sorry. Okay, so you can also get that from there. Gusto ko lang ng geometric importance. Okay, so going back. So let's try to do outside. Outside, Z greater than R. Then I'm left with 1 over 4 pi epsilon naught sigma 2 pi R and over Z. Tapos this will be evaluated sa R Z minus R to Z plus R. And that gives me oops 4 pi epsilon naught sigma 2 pi R Z tapos Z plus R minus Z minus R, that's plus, and that is 2R. Okay. Okay, so that is 2R, cancel mo nito. And then magiging 1 over 4 pi epsilon naught Z sigma times 2 del 2R to, so 4 pi R squared, and this is the total charge Q tot. Di ba? Nakuha natin yung sinolve natin dati. Inside, and we still have the correct answer. Inside, that will be Z less than R. So we have the potential to be this guy, 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught, and sigma 2 pi R over Z. That would be yung R mo evaluated from R minus Z, tama, and then Z plus R. We have 1 over 4 pi epsilon naught, sigma 2 pi R, Z, okay? Tapos, plug things in. Z plus R minus Z. So that's plus Z. Cancel R. We have 2Z. You have 1 over 4 pi epsilon naught. Tapos, sigma 2 pi R. 2Z. So, magiging 4 pi ito. 4 pi R. 2Z. Cancel Z. Cancel. And you're left with this. Okay, so lagyan ko ng factor na R over R para maging 4 pi R squared to. So I'm left with 1 over 4 pi epsilon naught para masulat ko siya in terms of Q total. Tama? Kasi 4 pi R squared. Then I have this. So constant yung sa loob ng shell na potential. So mas madali kumuha ng potential, di ba? Ganun lang yung potential. Ito yung potential kanina. Sa last time na sinolve natin. Ito rin yung problem niya. Pero this time, this one, gumamit tayo ng Gauss's law kasi given na sa atin yung electric field. So ito yung sagot sa inside. And similar yan sa sagot na nakuha natin. Outside, ganito rin. Okay, in terms of R nga lang. Which is just the same. Okay, no? So, mas madali kumuha ng potential. And then, recall na yung paano mo kuha electric field to get the field, you just have to take the gradient, negative gradient of your potential. Okay? And yung gradient, napakadali gawin yan. Right? Nice, di ba? So, makuha mo na yung field. Okay. Actually, yung pagiging madali ay subjective niya, no? Kasi baka mamaya sanay pala kayo kumuha ng hardcore integral. So, kayo bahala in life. Okay, so we continue with our next lesson. Okay. So yung exploration natin sa potentials pala will be further discussed in chapter 3. Dahil yung chapter 3 ay focused on the use of potential. Okay, so useful talaga yung potential natin. And marami pa tayong makukuwang things and techniques out of that para dumali buhay natin. Okay? Okay. Si Kazumi. Are you there, Kazumi?
Yes po.
Ano yung electric field sa loob ng spherical shell?
Ah, yung binigay po ba si Goslo last time?
Either way, kahit anong gamitin mo.
Wait lang.
Inside. Nasa problem set yan. Spherical shell din.
It's a problem set. Wait. Sorry.
Sige, ano na lang. Isipin mo, Gauss's law. Kapag may spherical shell ka, ano yung field inside? May ma-enclose ka bang charge inside?
Ay, inside po.
Inside.
Zero po ba?
Yun, zero. Tama. So, zero, inside. Outside, ano yung outside? Kuwari may total charge Q ka, ano yung outside? Actually, pili ka ng kaklase mong gusto mong sumagot. I-volunteer mo yung kaklase mo.
Ano? Kahit sino po.
Kahit sino. Sino ma-volunteer mo? Wala, ako pipili. Nakamute ka, Kazumi.
Sir, ako po pipili.
Ayaw mong pumili. Okay lang naman kung ayaw mong pumili. Kung nape-pressure ka.
Ayaw po.
Okay, ayaw. Ako pipili by random. Ross, are you there, Ross?
Sir, dito po.
Ano yung field outside? Spherical shell.
Sir, 1/4 pi epsilon naught Q over R or R
Squared.
squared.
Okay, R squared. Okay. So, ganun. Okay. Thank you, Ross. Thank you, and thank you, Kazumi. So, tingnan natin ngayon, paano natin ma-generalize yung mga bagay. Lalo na, pag titingnan natin yung field, di ba? Kasi sinabi nila na for a spherical shell, E0 outside, K Q over R squared. Yung K yung may constants na. Okay? Baliktad. Ano ba yan? Inside. Outside. So, tignan natin ngayon kung ma-generalize ba natin na kapag tumawid ba tayo ng boundary of charges, what happens? Kasi dito ang weird, di ba? Parang inside zero. Tapos, pag lumabas ka, nagkakaroon bigla ng electric field. Tignan natin ngayon kung paano natin ma-generalize yung mga bagay-bagay. Okay? Okay, so, let's say we have a random surface. Basta surface siya. Let's say, what can we have as a surface? Doon na lang. Let's see. Okay, we have a surface like that. Magic carpet. Oops, no pass. Ay. Okay. So, yan, surface yan, guys. Okay. Okay. Sipin natin ngayon yung surface. And then, what we're gonna do is try to find the electric field that is on the surface. Okay? Ayun yung mag-undo. Ayan. Siyempre, our trusted friend, Gauss, will solve for us. Pag may surface ka, pwede kang gumawa ng Gaussian pillbox. So, gawa tayo ng box here. Sige, sir, kaya man. Drawing tayo ng box. And another one, sa ilalim. Sa ilalim to. Okay. Ano ba? Hindi pa ito. Ay, nako. Dot. Dot. Yan. Sa ilalim to. And then, tapos, napapass through siya sa loob nung surface. Okay, so para alam natin tuloy-tuloy yung surface. Okay. So may Gaussian ka na surface na box. Tapos let's say na kunin muna natin tingnan natin gaano kalaki yung box natin. So sa top ng box, this is A. Tapos sabihin natin yung sides ay natin pula para makita. Epsilon. Okay? Epsilon. Ayan. Okay, now we do the Gauss's law. Napakadali. So let's do this. Wait na lang. And then we have, pagsasamahin natin yung E above plus E below. That must be multiplied over some area. Kasi E dot 8, iba yung flux. Okay, then we have sigma epsilon naught times yung area mo. Tama? Dahil ayun yung total charge enclosed. Yung total charge enclosed ay yung blue square, di ba? Okay. So may sigma yan times A, kung gaano kalaki yung box natin. And then, so let's say muna na kukunin muna natin yung kuwari random electric field to, no? Tingnan muna natin yung mga perpendicular sa surface A natin. So we have, let's do that, above plus E below. Okay? Okay. And then we have epsilon naught A. Okay, malinaw pa naman, di ba? Ang bago lang dito is hiniwalay ko yung mga electric field that is going up and then going down. And then yung sa mga sides, hindi natin pinansin dahil pinapansin lang natin muna yung mga perpendicular. Okay? Perpendicular surface, which is yung surface natin A. Ayan. Sir, hindi po ba 2A yung sa isang side? Okay, so nandito yung 2, no? Okay? Pag pinagsama natin ito, magiging 2A na siya. Tama ba? Kuha? Hiniwalay ko lang for now. Okay? Kuha ba? So, now I cancel A. And I'm left with E above. E above. Sige, kaya sir. E below. And that is sigma over epsilon naught. Okay. Si E below is pababa, si E above is pataas. Okay. And if we want to go at a singular direction, so isang single direction mo, go up, sabihin natin up para positive yung implication sa atin or intuition sa atin ng direction. Okay, so pag pataas yung field mo, that is positive. And then kapag pababa yung field mo, that is negative. So we relate now the E below. So actually, magiging E above minus E below siya. Okay? If we're gonna mind the directions. Okay? That's it. Okay? So, ang daya naman, bakit ba't di natin consider na yung gilid? So, sige, consider natin yung gilid. Sides. Ang E sides will be E dotted with A, and then yung total charge enclosed, sigma. Actually, hindi A dapat to, no? That would be epsilon. Tama? Namitan natin siya ng epsilon A. Tapos yung total charge, sigma A over epsilon. Not. And then we can actually do is to make our epsilon, yung box natin, into very, 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 very small. And this zeros out. Okay. So sa tingin niyo, feel pa rin kayo unfair sa ginagawa ko. So kukunin naman natin mamaya yung mga not perpendicular components. Okay? So ayan. So we have this that as you go along, as you go from a line from below to the upward side of a charge distribution, magkakaroon ka ng discontinuity that is sigma over epsilon naught. Okay. Sir, paano pag kinonsider natin yung mga parts na hindi convincing sa atin na mawawala? Okay, so let's do that. Gawin naman natin is, kuwari ito yung surface natin, which is yung nakahiga. Wait lang guys, naglalo ko na naman yung aking pen. Ay na magpasulat, bakit yun? Wait lang. Just gonna restart the app. Sorry. Okay, we're back. Going back. So we have a surface, side view na lang tayo. Yan, side view. So ayun yung mga charges mo. Ang gawin naman natin ngayon is to execute this formula. Alam natin to, di ba, from the previous lessons. Na kapag kinlose mo yung path ng E.dl, mag-zero out lang siya. Okay, and then let's say the path is, ano ba yung path natin dapat? Green na lang, para cute. So we can say that the path goes from here downward. Ayan. So paikot. Ganun yun. Okay, paikot siya. Clockwise motion. And yung mga field na madadaanan nito, kunin natin as E parallel to the surface. Okay? Okay. Then again, let's make it very thin. The path should be very, very thin. Okay? Okay. Di pala epsilon naught. Sanay na ako. And then, sige, let's evaluate. Basically, yung makukuha mo dyan sa mga parts na yan ay lagyan natin ng measure, no? Para hindi tayo nalilito. S box na may length and side LS. Okay? Okay. So, sabi ni equation natin, wait na lang. Sige, red. Tuloy natin sa red. E.dl is 0. And this is also equal to summing the paths. So E above parallel times yung length, di ba? EL, kuwari nagawa natin. Ganyan yung magiging itsura nung equation mo. Okay? Then plus yung S naman will be E side. Then that will be multiplied by the length S. Tapos E. So yun, sinasum ko lang lahat ng path. Another side, that will be S. Pero this is negative. And another one will be E below parallel L. And then again, I can make the contribution of S become very small by setting E. Ay, may length na pala. Okay. So si SIE. sorry. Okay, same lang yun. I can make the contribution of S become very small by making epsilon approach 0. So parang yung path mo, nakalapat na siya dyan. And this becomes 0. And then we are left with these two terms and magka-cancel yung L nila, which then gives me this guy. Okay? Okay, so anong set ginagawa natin? Mga ano to, yung ginagawa natin ngayon is pang-check ng solution nyo. Okay, so keep that in mind muna kung medyo naguguluhan pa kayo sa pinagagawa natin. So in general, I could point out that I could write this guy, E above, vector na siya, vector E, above, and E below. Okay? Sigma, epsilon naught. And what is N again? So N hat is yung normal vector muna sa surface. So kung ito yung surface mo, ito lang yung normal vector mo. Okay? Okay. So magkakaroon lang ng value to kapag nakatutok sa normal vector. Okay? And if kinuha mo yung parallel sa surface, ang lalabas, parallel, above, ito yung lalabas. Dahil wala siyang n-hat component, ang mangyayari is below, magiging 0 siya, di ba? Kasi walang n-hat. Tapos, yung mga perpendicular surface, will have a value of n-hat, which is sigma over epsilon naught. Okay? Okay, so in this continuity, sa surface, ang charged surface is given by this. Okay? Kapag lumagpas ka along charged surface, madadagdagan ka ng sigma epsilon naught. Okay? Okay, so tandaan dito, kaya naging negative kasi gusto natin dumaan from below to above. Kaya naging negative natin yung sign. To be consistent, no? Kasi we're not just looking at the flux, we're looking at the directions of the electric field. Okay, okay? And then, what about if titingnan natin yung potential? Okay. Okay, kapag meron tayong surface, again, gagawin natin yung trick natin. Kapag may surface ka, then you're going from point A to point B. Say red na lang. Point A to point B. Going from here to there. Going from that point to that point. Going from that point to that point. I can say that the path is just epsilon. And then if I really shorten that out, yung epsilon natin, gawin natin limit as epsilon goes to 0. And then I would have that B above should be minus B below should be 0. Okay? Okay? Kasi mag-0 out lang magiging mag-integrate at the same point. Parang, let's say, we can write B in terms of A. We can just write B in terms of A plus epsilon. Sorry, the small epsilon. Okay. And then if I plug in that in the integral, A to epsilon to A plus epsilon. And then if I limit epsilon to 0, magiging A to A siya. And that gives me 0. Okay. So this tells me that B above, B below, which is this. Okay? So passing through a surface. Again, pag nag-pass ka raw sa surface na may charge distribution na sigma, you'll be getting a same potential below and above. Okay? Okay, we can actually write E as a function of V. Diba, alam natin na E, sabi ko lang kanina, gradient siya ng potential. And then if we're gonna write that, so negative, ito lang yan, ipa-partner ko lang, negative above minus negative delta V below. Okay? Okay, then sigma epsilon naught n hat, and that just gives me that factor out ko yung negative na, factor out ko yung negative, tapos lipat ko na lang sa kabila. Then I'm left with above this one. Okay, ba't ko ba sinusulat? Nandito na pala. Pag pinactor out mo yung negative, tapos nilipat mo sa kabila, lalabas ka dito. Okay? And then, you can further simplify this para hindi na kayo gagamit ng del operator. You can actually write this as the partial n sa B above minus partial with respect to n ng V below. 1 minus epsilon naught sigma n. Okay, malinaw ba to sa lahat? Malinaw ba to sa lahat? Medyo parang, hala sir, saan nanugot yan? Okay, yung gradient natin can be written, diba yung gradient mo is just equal to n hat partial n plus other terms. So, terms, yung unit vector niyan, tapos partial with other terms. Okay. Other arbitrary na lang. Okay. Okay. So, yung ibang terms, ganyan. Pwede mo sulat. Okay. Ang kailangan lang naman natin is itong part. Okay. So, pag ginawa mo yung gradient dito at the left-hand side, and the right-hand side tells you that n hat lang yung matitira. Therefore, yung makukunin mo lang dapat is ito. Kung ano lang yung may n hat lang din, di ba? Ang weird naman na pag ginawa mo yung gradient on the left-hand side tapos may other terms ka, tapos yung right-hand side mo, n hat lang, that is weird, di ba? Mali ginawa mo, ibig sabihin. Okay? So, we can simplify this as the partial derivative with respect to n. Kasi n lang na lang matitira. So, wala nang n hat dito. Sorry. Okay? Okay, does it make sense? Siyempre, gagamitin natin yung mga example natin. Siyempre, favorite natin is charged spherical shell. Okay, so kanina, di ba, introduction natin is inside is wait. Gamitin natin yung white. Blue na lang, blue. At ayaw na lang. Sige, red na lang. 0, tapos outside is this guy. Okay? And then, Q is the total charge. For total charge Q, makukuha natin yung sigma as multiplied mo yun sa 4 pi r squared. Tama yung surface area ng sphere mo. And you can have sigma as something that is in terms of Q, 4 pi r squared. Okay, anong sabi natin sa electric field when it crosses a boundary. Meron siyang discontinuity niya sigma epsilon naught, sigma over epsilon naught. Meron ang electric field natin is radial component lang. So walang theta and phi that goes around your sphere. So walang E parallel sa sphere mo, tama? Lahat perpendicular kasi radial component lang. So we have inside. So E below, what is E below? 0. Inside kasi 0, di ba? The surface ng sphere mo at yung below is R less than R. Above is R greater than R. Okay, so E below is 0, E above is 1 over 4 pi epsilon naught. And then Q over R squared. Okay? At the surface, this becomes 1 over 4 pi epsilon naught, capital R squared, kasi nasa surface ka na. And then if you can see here, I can write this in terms of your sigma, which is Q over 4 pi R squared. Then I have sigma over epsilon naught, which makes sense. Tumalon si E below, papunta kay E above with an amount of sigma over epsilon naught. Okay? So if you're gonna check your work, you can do this. Diba? Does my answer make sense? Ganun. And then let's try for the, okay, so di pa tayo tapos pala dito. This is yung E above, E below. What is yung E perpendicular? Outside, wala, 0. Diba? Kasi R hat lang yung meron ka. And then above, E below. Wala din, di ba? 0. Dahil sure ka na 0 yung field sa loob ng spherical shell mo. So equal sila. Equal yung E above at E below na parallel sa surface mo. Okay? Okay? Okay. So lastly, sa potential naman try natin, ang meron lang tayo is B above is equal to B below. V below. Okay? So ito yung outside will be above and below. Okay, at the surface, this is constant, di ba? So wala ka nang babaguhin. 1 over 4 pi epsilon naught Q over capital R. And at the surface, this is 1 over 4 pi epsilon naught Q R. Are they the same? Yes, they are the same. Same. Okay? So it makes sense na passing through a surface with the surface charge sigma, your potential does not change. Okay, so pag nagsasagot kayo, okay, solve kayo ng, kasi di ba marami kang region na sinusolve pag mahirap na yung problem. Okay, so titignan mo ngayon mga boundary conditions mo, kung tama ba. Okay? Okay. So yan, pag potential kinuha mo, dapat at a surface charge, yung potential sa baba, equal lang dapat sa potential sa taas. And sa E, kailangan, pag perpendicular, may talon ka na sigma over epsilon. Okay? Amazing, di ba? Again, yung mga tinuturo natin, yung mga dinidiscuss natin will be something that are techniques na magagamit natin in solving our problems. Okay. Another one. Lesson 6. Okay. Ito ay medyo confusing, so keep up. I mean, mag-solve kayo, magsulat kayo, or anything na tingin yung useful. Okay? Okay. So, sige, let's go. Ang topic natin ngayon will be work and energy in electrostatics. Okay? Na-solve na natin yung pagkuha ng electric field potential. Ngayon naman, tanungin natin kung ano yung work or energy sa mga configurations natin. Okay, work. We define work as this guy. Okay? So, very straightforward. Alam natin to. Na yung work will be just the force that you do along a path, dl, that na ginagamit mo sa A to B. Okay? Okay? And force is just Q, then the electric field. Okay? So, kunwari, gawin muna ko. Kunwari meron kang Q. Pag may charge Q ka, it produces an electric field E. Tama. And then gusto mo meron kang dadaling charge sa tabi niya na Q. Then what is the force that is needed for papunta doon? Okay, so itong Q mo, may ginagawa siyang force na F Q on Q. That will be Q epsilon. Q, then the electric field. Tama? However, yung ito mo, ang required force para mapunta ka dito is yung reverse lang. Q on Q will be Q. Okay? Okay. So, nire-reverse mo lang yung mga bagay-bagay. Okay, so para makontra tong force na ito, yung Q, then the electric field, the force, ang kailangan mo is yung negative nito. Okay? So we have that here. In log-in lang, very straightforward. In log-in lang sa equation ng work mo, which is F.dl, plug in natin si negative QE sa loob. We have this. Okay? So si E, pwede mo siyang isulat na, again, negative del of V or the gradient of V. I can plug in that here and then I can plug in that there. Tapos, gamitin natin yung fundamental theorem for gradients, which is this guy. Okay? Diba? So, kapag pinlog in mo na yan doon, sulat natin, sige, negative Q, integral A to B, delta V. So, negative E naman to. So, delta V na nalalagay ko. Dapat pala mawawala to. Ay, magiging positive to. Tama? Magiging positive to kasi negative to, tapos negative to. Pag pinlog-in ko si E, magka-cancel yung positive. Ay, magka-cancel yung negative. Sorry. And then, the right-hand side gives me Q. By using this equations, yung fundamental theorem mo, this integral, sorry, that DL to. DL vector. Okay. So by using this, makikita mo na this is D minus V A. Okay? Okay. Very straightforward pa naman. Plug in lang. Okay, so ayan. And then if you simplify, bale, gusto mo na lang potential na sa kaliwang side. So yung work mo, so W over Q, ayan, scaled na siya ng Q. And then, the other way around is tingnan natin ngayon kung paano natin dadalhin yung charges from point A to point B. Ngayon, ano yung usual form ng potential mo? Potential mo for a single charge will be charge 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught. Then that will be your charge Q over R. So what is this at infinity? At infinity, so V infinity is just 0. Okay? Kuha ba? So R dapat. Okay, so pag pinlog in natin si infinity sa R, magzi-zero out lang tong whole thing mo. Okay, so we can bring your charge from infinity, okay? From infinity towards your point R so that we can have W over Q, that will be V R, kung saan natin gusto ilagay, and then hatakin natin siya from infinity. So that we have this guy to be 0, then your work can be written as this. Okay? Okay? Malinaw. So let's do things, no? Okay. Paano ba natin ito magagamit? Suppose we're trying to assemble 4 charges. Random configuration. Okay? So matindi-tinding imagine ito. So ang kailangan ko isipin nyo, kung meron tayong space na blanco, vacuum, may vacuum space tayo, theoretical vacuum. Then I'm gonna assemble charges there. May 4 tayong assemble na charge. Okay? So bringing in the first charge, so yung work will be yung i-add natin yung work done kailangan para malagay si charge 1, then si charge 2, charge 3, and charge 4. Okay? So may 4 tayong charge, so may mga gagawin tayong calculations. Okay, si work 1, W1, anong kailangan natin na effort para malagay din si charge? Ngayon, wala pang kukontra sa kanya. Dahil wala pang laman yung space natin. Tama? Okay? Diba? So vacuum yan. Pag nilagay mo yung charge mo, effortless ka malalagay yung charge mo dyan. So ang work done will be 0. Tama? Next, work number 2. Si work number 2 ngayon, however, since nilagay mo na yung unang charge doon, nilagay mo na, pag ilalagay mo ngayon si parang pangalawang charge, kukontrahin siya nung, or i-attract or kukontrahin siya nung unang charge. Tama? Okay? So may effort ka na gagawin para mailagay yung pangalawang charge doon. And that effort will be this much. Okay? So si Q, kung ano ilalagay mong charge doon, that will be Q2. Tapos yung potential due to 1, kasi di ba nandun si charge number 1. So may potential siyang pinoproduce na V1. So kung saan mo siya ilalagay, si R2. Okay, so position ni charge number 2. So saan mo naman siya ilalagay? Random. Okay? And we know yung potential ng isang charge can be easily written down. What is that? 1 over 4 pi epsilon naught. Yes, 1 over 4 pi epsilon naught. And then that will be Q1. Tama? Potential kasi ni 1 to eh. Then the separation between Q1 and Q2. That is 1, 2. Okay, so ito ay R. Ayan, pangit lang sulat. Okay, so this makes sense. Kuha pa ba? Now, what do I need to do? Ilalagay ko na ngayon si third charge. W3. Okay, so sa W3, makaka-experience siya ng dalawang potential na. Kasi nandun na si charge 1 at nandun na si charge 2. So that is V1 at the position of R3, at the position of charge 3, sorry. Then, yung pinoproduce ng pangalawang charge at the same position, of course. Okay? And then, I'd have Q3. Factor out ko na yung 1 over 4 pi epsilon from both of these potentials. Para tayo mahirapan magsulat. Okay, so that's that. Then the potential that is produced by V1 will be, of course, from Q1 to, that is coming from 1 to 3. And then plus the potential due to Q2. So may charge from Q2. And then the separation from 2 and 3. So that is 2, 3. Klaro? Wala pang malabo. Then, number 4. We do this. Okay, Q4, very straightforward. Then, may tatlong charge na nagsistay sa theoretical space natin. Si Q1, Q2, Q3. And then, lahat sila may potentials. And then, by superposition, add mo lang. Parang kanina lang din. So, may V1, V2, and then V3. Okay, so at the position of Q4, okay? So hindi ko na sinulat yung mga parentheses R4 kasi pare-parehas lang naman sila. Okay, and then let's do this. Q4. And factor out 1/4 pi epsilon naught. Tapos sum the things that are giving off their potential. Okay? So Q1, 1. Tapos 1 to 4, tama. Q2 are 2 to 4. And then Q3, 3 to 4. Klaro? So yan, nabuo na natin yung 4 charges natin. Ang kailangan natin is yung total work or total energy na kailangan nating exert para malagay itong mga bagay na to. So, sulat ko lang silang lahat. Okay, so kailangan nating i-add yung mga blue. 1/4 pi epsilon naught, Q1, Q2, R1, 2. Okay, ito lang yan. Next will be 1/4 pi epsilon naught, 2 charges. Okay, so that will be Q1, Q3 over R1, 3, tapos plus Q2, Q3, R2, 3. Lastly, this guy, 1/4 pi epsilon naught, factor out ko lang. And then, I have 3 terms. Pagod. Okay. Contribution ni 1, papunta kay 4, 2 kay 4, 3 kay 4. You write that down. Then Q1, Q4. That is 1, 4, Q2, Q4. Oops, sorry. That is R24. Lastly, Q3, Q4. Okay. Separation ni 3 at 4. Okay. So I have to add this guy right now. Okay, so ang gawin ko lang is total work. W dot. Okay, add ko muna, labas ko si 1/4 pi epsilon naught dahil hassle siya. And then I'll sum things. That is, pagsama-samahin ko yung may Q1 sa unahan. Q1, itong unang tatlong term. Okay, so 2, 3, 4, tapos 1, 1, 1 lang yung mga left-hand side indices nila. Okay, let's do that. Q1, Q2, R1, 2, plus Q1, Q3, R1, 3, then Q1, Q4, R1, 4. Okay? And then I'll add yung mga 2 naman, dalawang terms na lang. Bale 2, 3, tas 2, 4. Okay, let's do that. Q2, Q3. Sorry, but may comma. Hindi ka nagsusulat. Equation to. Okay, Q2, Q3, R2, 3. Nakalito, no? Pagod to. Then 2. So pa rin tayo. Q4. Oops, mali naman. 4. Then R2, 4. Lastly, in-arrange ko lang na ganyan para cute na para masarap sa mata. Okay, so si 3 and 4 na lang yung natitira. Okay, so si 3 and 4 na lang ang natitira. Q3, Q4, R3, 4. Okay? Okay, so ayan. So ito rin yan. Sinulat ko rin dito. Ayun, ayan sila. Okay, so ayan yung total work na kailangan natin para ma-assemble yung ano natin, charge configuration natin. Now, what if arbitrary charges yung ilalagay natin? So that is, sabihin natin N yung ilalagay natin. Okay, so tingnan natin yung pattern syempre. Balik tayo sa green. Kuwari, for N charges, you can write this down as U1 over 4 pi epsilon naught EC. Then, since I have two indices, I can have two summation values, I, and then J. Okay. Okay, so si I na gawin na lang natin si I na yung unang index nila, si J yung pangalawang index. So si I magra-run siya from 1 to 3 kung 4 yung ano natin, so N minus 1. Ito N minus 1. So yung total charges natin kanina 4, di ba? Tapos ang inabot niya lang is 3 lang. So N minus 1 yung gagawin natin. Then it started from 1. That is 1. Then si J, paano natin bubuin si J? Si J will be always greater than I. Okay? Kung 2 to, magiging 3 siya. Kung 3 yun, magiging 4. So let's just write down. Let's delete. Yung nalagay natin. Equal sign nalagay natin. So gawin ko ay J is greater than I. Then it will run from 1. I can ang kailangan ko na lang pala yung upper end niya. So upper end niya will be yung final value niya, which is yung kung ilan yung charges mo, which is N. Okay? And then I just have to put the things down. Qi, Qj over the separation will be Rij. Okay. Okay, let's put this down in the grid. 1, 2, 3. Yung 4 na example natin kanina. No? So this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Para ma-imagine natin, may gagawin kasi tayo dito na baka hindi nyo mahirapan kayong imagining. Okay? So we'll just take things slow. Okay. Kapag si I ay equal to 1, si J mag-run. Kapag si I ay equal to 1, si J ay mag-run from 2, 3, 4. 2, 3, 4. So this is J, this is J, this is J. Okay? And then kapag si I ay 2, ang run na lang ni J will be 3 and 4. Tama ba? Let's check. Tingnan natin. Kung si I ay 2, magiging 3 and 4 na lang yung tatakbuhan niya. Then lastly, I have I. Then this has to be J. Okay? Okay. Itong number 4, hindi naman siya kinakount. And then yung 1, hindi rin siya nakakount kasi yung separation mo can't be the same number. So paano magkakaroon ng separation doon kung at the same point lang? Tama? So si R hindi rin nag-exist to 4, 4 kasi hindi mo pwedeng i-measure yung separation kung wala kayong separation. Tama? Okay, so wala lang yun. Now, what I want to do is pwede akong mag-count din mag-count ng tuloy-tuloy such that I can do this, no? Okay. Palitan natin ang color. I can also count the other side. So I can just, sorry, may J din pala dito. Si J pwede ko i-run over everything except for I. Okay? So ang gusto kong mangyari is pwede natin i-switch ito to something that is J not equal to I. And then, okay? I want to do this. Okay? Yung sense niya makikita natin mamaya. And when I do this, ilan yung nadadagdag na terms? Okay? So, ilan yung nadadagdag na terms? Bilangin lang natin yung pula. 1, 2, 3, 4, 5, 6. And yung original terms natin, merong 1, 2, 3, 4, 5, 6 terms. Okay? So, nadoble yung number of terms mo. Diba? And to compensate, lalagyan natin ng 1/2 if we're gonna do that. Okay? So, let's write that down. Let's change things. So the work for combination of charge for arbitrary charge distribution with n charges will be 8 pi epsilon naught kasi may 1/2 ka na extra factor. Okay, and then I have this for I, run ka from 1 to n minus 1. Okay, imagine this. If ginawa ko siyang n, may mangyayari ba? Okay, so kuwari ginawa ko itong summation natin. Oops, sorry. Break tayo. Ibang color na lang. Okay, so kapag ginawa ko na kuwari I to 1, then balik tayo, di ba dapat 4? Yung example natin kanina is 4 plus 3 lang gagawin natin. Then J ay 3 lang din. If I'm gonna do na sorry. Dapat 3 nilalagay ko? Dapat 4 to. Okay? J greater than I. Okay? So, ang final value will be I is to 3 and J is to 4. Okay? Tama? Ayun yung mga final value, di ba? Kasi J is greater than I, which is 4. Okay, so ayun yung final value. And that makes sense kasi nakita natin yun sa pulling term natin na I is 3, then J is 4. Okay? What if I'm gonna do this? Para lang maganda, para cute, no? Gawin natin yan. And then J greater than I 4. What is the last term? So pag ginawa mo yun, yung last term mo will be I is equal to 4. Then what is J greater than I? J greater than I could be 5. But 5 is not included in the summation. So this just zeroes out. Null yung position ng J is equal to 5. So I can do this kasi hindi naman nasasama yung J is equal to 5. Okay? Okay? So gawin ko yun. I'm just gonna do that. Okay, that's it. And then go back to green. And then I'm implementing this J, I, N, and then Q, I, Q, oops, that's G, sorry. J, then the separation between these charges are I, J. Okay? Okay? Whew. Intense. Ano anong gusto natin mangyari, no? Kailangan magamit natin yung pag-simplify na yun para mapadali buhay natin. Okay. Okay, so let's just separate things. So, Ben, sir, palipat-lipat ka ng ano. Okay? Ilabas ko yung 1/2. Then may ipapasok ako dito. 1/4 pi epsilon naught. Then J not equal to I. And N. Tapos, I'll take this one out, QI. Ang matitira na lang is Q. Oops. Ay, dapat pala, nasa loob siya. Kasi may nandun sa loob yung summation niya, di ba? Budaya naman kung pwede siya lumabas. Bawal siya lumabas. Okay, QI, ni-factor out ko lang. Tapos, ang matitira ay QJ. And that will be the separation I. Okay. So, this guy is just the potential. 1/2 QI V of R. Okay? Okay? Okay. So, ito lang is definition lang natin ng definition lang ng potential natin from way back. Okay? So, ang point ng pag-shift from here is para mabuo natin yung contributions lahat ng potential. And by that, nasulat natin siya as V. Okay? Okay, so, ayun. Ito na yung work done. Kaya sa mga work natin, may 1/2 na factor. Okay, yung summation po from ng I is from, ayun nga, sinasabi ko dito, pwede naman gawin natin n-1. Yes, that's okay. Pero to make it look pretty, sama ko yung n, di ba? Kasi dito, ito yung original natin, di ba? Ito yung OG natin. Tapos yung example natin is n is equal to 4. Tapos sabi natin na yung first index or first summation from I will run from 1 to n-1, which is here is 4 minus 1, and that is 3. Okay? And we find out that the final value is this guy. Okay? And when gusto kong maging pretty yung notation natin, sinabi ko na pwede ko namang gawing 4 to. Kasi pag ginawa ko yun, magiging null yung huling value nito. Okay? Magiging null yung huling value niya, which is j is equal to 5. Okay? And wala yun sa bounds nung summation mo. So that becomes just 0. So yung last value nito will still be 3 and j is equal to 4. Okay? Okay? Kuha ba? So, ayan, isa sa mga pinakamahirap na math is magbilang. Diba? Ang hirap niya imagine minsan. Kailangan you take things slow. Okay? Ayan. So, we have this word. So, ano siya, no? Familiar form niya. Kasi, diba, yung mga work, kinetic energy natin, 1/2 mv squared, gano'n, diba? So, may lagi may 1/2. Kaya natin ginawa yung part niya. Okay? So, nasaan na tayo? Ang layo na ng lupalop na inabot natin. Ayan. Okay? So, nandito pala sila. Nalagay ko pala. Alright? So, yan. And syempre, pag nasulat mo na siya as something like this, you can now write them as a continuous charge distribution. Diba? Okay. So, we have this. Okay na ito, green. Kapag ginawa mo na siya ngayon sa charge distribution mo na rho or sigma or lambda, you'll have this. And yung similar forms niya will be yung sa sigma mo. Papalitan mo lang yung lambda with yung rho with sigma. Then yung dito magiging dA. Kapag ginawa mo lambda, magiging dL. Okay? Okay. And then this, we can only get the energy if we're given a potential V. However, paano kapag may binigay sa atin is energy? Paano mo kumpitin yung electric, yung energy mo doon? Diba? So, hirap, di ba? Derivative ka pa. So, gawin na natin ngayon. Transform mo na para meron ka ng ready equation na ipa-plug in mo na lang si E. Okay? So, ito, kinuha natin to from the last lesson na divergence of E. And nakita natin that that is rho. Ayan, rho over epsilon naught. Then, kapag kinuha mo yung flux niya, lalabas yung Gauss's law. Kaya napunta tayo sa Gauss's law, di ba? Okay? Okay? Okay. So, yan. Napunta tayo sa Gauss's law dahil nakuha natin ito last time. And then, we can use this to plug in it there. So, yung rho mo, pinasok lang doon. Napakadali. Yan. So, siya napunta. Claro? Claro. And now, this is a more problematic equation kasi meron kang E and then meron kang V. So, ayaw natin yun, di ba? Kasi isa nga lang hinahanap natin, mahirap na. Yung E pa lang or V pa lang, mahirap na. So, we want to transform this such that malilipat natin yung derivative towards the potential. Kasi yung derivative ng potential, alam natin that E is negative of the gradient of V. So, we want this. And kung gusto mo mangyari yun, kung gusto mo makapaglipat ng derivative under the integral sign, kailangan mo mag-integration by parts. Now, we have an integration by parts na weird. Okay? Sa chapter 1, kung nagbuklat kayo ng libro nyo, makikita nyo na marami tayong formula for your integration by parts. Now, this is not your simple integration by parts dahil gumagamit na siya ng del operator instead of your normal derivatives. Okay, so may derivation to doon. Tignan nyo na lang. And again, hindi ko kayo pupulisin kung gagamitin nyo to sa mga solutions in your prob set. Pwede nyo sabihin na, okay, the integration by parts for a theoretical function f and the vector a is given by this. Okay, so kopyahin nyo lang. Pwede yun. Okay, ayan. So we have this and we can easily pattern this guy to this guy. So A is to E and F is to V. Okay? Vector. Para ma-distinguish natin yung vector function sa scalar function F. Okay, and integrals are okay. Integral is with respect to the volume, d tau. Okay? And then I have this. Tama? So let's do that. Magiging negative na kung yung A natin gagawin natin E, magiging E dotted with the gradient of V. Okay? And that is integrated along d tau. Then the surface, closed surface integral. Okay. Closed surface integral will be FA.dA. So this is FA.dA. F is V, A is E, dotted with dA vector. Okay. So, ayan, di ba? Very straightforward. And then I know this guy. That is that. So, pasok ko si negative dun para mag-E siya. And then, I'm left with yung work mo ngayon will be epsilon naught over 2. Epsilon naught over 2, this guy. Ito pa yung kanina, hindi naman natin sinama. And then, ito ay magiging E din. Magiging E. So, E.E is just E squared. Okay? And then, the second term is unchanged. Okay? Okay, sir. Problematic pa rin yung binigay mo sa amin. Merong potential, merong electric field. Now, we ask, saan ba tayo mag-integrate? Anong volume ba to? Anong surface ba to? Okay? Okay. pag in-integrate mo yung d tau to infinity, ang lalabas din infinity. Okay? Okay? Tapos, ano ko ba i-explain ng ang gusto kasi natin, matanggal tong second term. Okay? Okay. So, ang usual na form ng V, 1 over R, and then yung E mo would be 1 over R squared. Okay? And then sa second term, will be, ang mangyayari will be something that is integrated along, kuwari, 1 over R lang siya. Tapos, multiply mo ng 1 over R squared. Tapos, yung dA mo will be something that is R squared in dimensions. And kapag integrate mo to all over space, so R reaches infinity, this guy vanishes. Okay? So this guy naman, sa E squared, okay, sa E squared, paano ba in-explain to? Okay. Okay, so sa E squared naman, since this is a positive term, dahil sure ka positive to, so sure ka na positive lang yung E mo, ang mangyayari sa integration mo with respect to the volume as it increases towards infinity is lalaki lang din to. Hindi siya mag-vanish, no? So lalaki lang siya ng lalaki. So yung first term mo, lalaki lang ng lalaki. Tapos yung second term mo, it vanishes. Okay? So in the sense, you can integrate all over space. Then you have this guy. No. Alin sir yung valid namin gagamitin? Is this guy or this guy? Okay, so either way, you'll get the same answer. May exercise dun sa libro na pwede mong gawin parehas and you'll see that things are actually the same. Okay? Kaya lang natin ginawa kaya lang natin tinry integrate all over the space para mawala tong hassle na term. Okay? Kasi may potential siya and electric field. Ang gusto lang natin, electric field, plug in na lang natin. Kasi kanina, pwede naman na potential na lang pa-plug in ko. Okay? Okay? So, usable parehas yan. You can get the same thing. Okay? And then, if you want more satisfying, so parang host ka naman sa amin eh. You can have more satisfying discussions kung titignan nyo yung book. Okay? So, basa tayo. Okay. Sige, konti na lang pala natin dito sa class. Si Kyla, are you there? Si Eliza?
Yes po, sir.
May nakikita ka bang inconsistency dito?
Parang wala naman po.
Okay, sige.
Hindi
Okay lang
po
yan.
ako sure.
Okay lang yan. Si Jello, may nakikita ka ba ng something dito?
Wait lang po.
Kung wala, okay lang. No? Okay, so may tanong pala tayo. Okay. Sir, kapag ginamit po namin yung nasa taas na equation, i-integrate po siya along the volume lang. Pero kapag ginamit po yung nasa baba, i-integrate siya all space. And magiging same yung sagot po nila. Yes, magiging same yung sagot nyo. Okay, so pag itong part na to, pag ginamit nyo to, mag-stay lang kayo dun sa integral nyo V. Okay? And yung surface na gagamitin nyo will be related to this. Magka-relate dapat sila, okay, di ba? Kuwari, gumamit ka ng volume na sphere na volume with 2R na radius. So yung gagamitin mong surface integral will be that spherical shell. So with 2R. Okay? Okay? So same lang sila. Nagko-compensate yung pagiging all space nito sa terms na to. Okay? Pag niliitan nyo yung volume. You can try that in your book. Nasa book siya. Amazing pag ginawa. Okay? So, Jello, may nakita ka ba inconsistency dito?
Hindi ko po sure yun, sir. Pero, wait lang po. Hindi ko po sure. Sir. Pero, kapag po, di ba, V times Q, magiging... Dyan. Hindi ko
Okay lang,
talaga-
okay lang, wala. So, okay, sige, plus 5 sa prob set. Next. Over 20 lang yung prob set next prob set. May makakasabi ba kung may inconsistency dito sa dalawang equation na to? Five, 4, 3, 2, 1. Wala nakaka Okay, so tingnan natin yung signs, no? Tingnan natin yung signs ng dalawang to. Okay, so tingnan natin yung sign. Anong sign nitong unang term? Epsilon naught is a constant. Alam natin yung value niya, positive yan. E squared is a positive value. Then d tau is a volume and it is a physical object. So hindi pwedeng maging negative volume, di ba? May utang na volume, walang ganun. So this whole thing is positive. However, if we look at this guy, yung Q mo pwede magbago, di ba? Yung charge mo, yung nilalagay yung mga charges, pwede siya maging negative or positive. Okay, so what's wrong with this? So kung titingnan nyo, maganda yung explanation ni Griffiths, pero TLDR, too long didn't read. Actually parehas to tama. Okay? Yung itong equation na to is for determining what is the required work or energy to build a configuration of system. Okay? And this works only on set of charges o sa mga individual charges mo. Okay? So dito, ina-assume na yung ginagamit mo ay charge distribution. So there was a charge in your space in your space already. Dito kasi nag-build tayo ng charges. Kaya we have this equation. This guy, ito, mas useful to, mas maganda yung formulation ng na to. Kasi ina-assume na niya na yung configuration, it exists there in the first place. So, as a caution, huwag niyong gagamitin to kapag may individual charge. Okay? So, kuhanin niyo yung work or energy ng isang single charge. Ang makukuha nyo, infinity. So that doesn't make sense. Infinite energy pag single charge. Again, hindi nag-work to kasi kailangan charge distribution na. Okay? Yung pangalawa, you're building charges in the first place. You're building a charge distribution. Okay? Okay. So now some notes, where is the energy? Yung energy hindi natin alam. Okay, it can be in the charge, it can be in the field. Kasi 'di ba, yung ilaw mo, 'di ba? Alam naman natin yung ilaw natin may energy that is related to the frequency. But light itself is chargeless, wala siyang charge. Okay? Pero may energy siya. And alam naman natin na yung light is made up of electric fields and magnetic fields. Okay? So kung titingnan natin, it can be in the charge, it can be on the field. Let's see. Okay, superposition doesn't work. Okay? Sa total, ang weird pala ng sentence construction. Superposition does not work when calculating the energy or work. So dahil E squared ito, kung may dalawa kang field, E1 at E2, you have this guy. Plug in mo sa E mo, E1, E2. And then, kung papansin mo, kung gagawin mo yung dot products nito, ang mangyayari is, meron kang cross terms. Yung 2E1, E2. Okay? So may cross terms ka. So hindi pwedeng mag-superposition kapag nagko-calculate ka ng energy. Dahil wala na tayong time, wala nang time for an example. So prob set, next week na, Friday, pahinga kayo this weekend. Okay? Okay, so ayan. Prob set. Alam ko naman nakikita niyo yung mga sagot sa ganitong bagay. Ang gusto kong mahasa sa inyo is yung kung mag-iisip ba kayo ng bagong solution or at least kung paano kayo magdi-discuss. Kailangan yan para sa thesis. Kailangan matuto kayo marunong mag-discuss. Okay? So, tignan nyo na lang itong example sa libro, example 2.9 for mastery of this guy. Okay? So, yung gagawin niya dito, yung way na pagsagot niya dito will be using two equations, dalawang solutions to. Tignan nyo ngayon kung gagamitin niya to, tapos gagamitin niya rin yung charge distribution. Okay? Okay, ayun lang. So, stop share. May questions ba? Okay, kung may questions kayo, you can actually send sa Canvas. Pwede kayo, again, kung may papo-point out kayo na things sa akin na mali naman diniscuss mo, sir, kontrahin nyo lang ako sa discussions tab and magkaka-bonus points kayong lahat, di ba? Masaya buhay natin. Amazing. Okay, thank you guys for staying. Grabe. Hindi ko kayo gigisahin next year. Charot lang. Okay, sige. Thank you for staying in the class. Thank you. Class dismissed. Dinner time na. Bye.